if you want to see where is this architectural design located or lies in our overall process of software engineering, see this green box. This is the way, this is the place where architectural design comes in. And after that, the last topic that I told you, that is testing, and that's the last topic. Alhamdulillah, we have gone through all the remaining topics. So here we are studying it today. What is architectural design? Architecture, as I have explained to you, the terminology is not new to you. These have been explaining to you a couple of times in our last lectures, in our previous classes. Okay, once again I will tell you. So architecture is basically logical arrangements of different components is called architecture. Like architecture of your home, architecture of your building. Where are the rooms located? Where is the kitchen? Where are the doors? How far, how wide will be the rooms? What will be on the first floor? What will be on the second floor? And so on. All these arrangements are called architecture. So you want to design the architecture, yani you want to make decisions how the architecture would look like. So architecture of a system of your software, it refers to the design of the structure of your system, including the interfacing and including the interactions between major components. So what is interfacing? Interfacing means what will be the methods which will be used to access other components. How will you be accessing the other components? We are talking about the internal architecture, okay, as well as the external architecture. So how one component will interface with other component, yani what will be the functions that will be used. Number two, how they will be interacting with each other, yani what messages they can send to each other, what services they can provide to each other. This is, and another definition, you can say the software architecture, it refers to the fundamental structure of a software system. Basically, when you are designing the architecture, it's a decision-making process in which you determine what will be the components of your system and how those components will be interacting with each other. The architecture of your software system has a significant impact on the performance of your software, of your system. What kind of performance you are targeting, it depends, it takes an important measure to decide what type of architecture you will use. In next slides, inshallah, I'm going to show you different architectures, which are the major architectures a lot of people are using. So you have to select one of them, or you can modify them according to your needs also. So the performance of your overall system, it really depends upon the architecture you choose, the efficiency of your system, security, of course, maintainability. These parameters are very important with respect to your system architecture choice. So you choose architecture number 1 or 2 or 3, they have different performances, they have different efficiencies, security measures are applied differently, they have different maintainability. And your architecture design is a primary artifact for your conceptualization. Yani, how you are conceiving your system, how would it be, what will be its different components, how will they be related to each other. So this is, everything is in the brain, but you have to bring it in reality, yani make the architecture, yani make its picture, make its model, use for example UML, draw it so as we can really feel it, we can really see it. And for its constructing, yani on the basis of whatever the conceptualization you have made, you will construct it. Later on you will manage it, later on you will improve it, evolve it. And if there is any flaw that is left, major flaw, if there is any major flaw in our architectural design, then it may result in project failure, because if you missed some of the important thing, or you make a wrong choice for your architecture, then maybe the performance, efficiency, and security requirements are not met, it will mean essentially that the project is not successful. So we have to be very careful while selecting architecture. What is the process for architectural design? What are different steps? And essentially, there are 5 or 6 different steps. 6 is the review, so you can call it a step also. The process starts by determining the design objectives. What are the objectives that you want to meet? As I said, what is the performance that you want to have? How efficient you want to have your system? How secure you want to have your system? And any other objectives. Okay, then in step number 2, you determine the type of system that you, first objective, second type of the system that you will be dependent and you will be developing. Here the question comes, what are the existing types of the systems and what are their characteristics? So we are going to study the existing types of systems and their characteristics. This you will take as input in your decision here. What will be the type of system you will be using? After step number 2, the next steps are 3 and 4 together. In one branch you go to step number 3, in another branch you go to step number 4. In step number 3, you apply some of the existing architectural styles. So yani existing architectural styles are there. You choose one of them or more of them or combination of them to apply to your system. And of course, not everything which is ready-made or which is available is ready for you. You must make some of the customization. That is your step number 4. You have to adjust with the existing styles to meet your objectives, to meet your needs, and you should do some customization for that. So here is the customization, here are the ready-made solution. So you make a combination of both of them. Some part of your design comes from ready-made design, some remaining part comes from your customization. So partial design comes from step number 4. Another partial design part comes from your step number 3. You join this partial design and you also this partial design to make up your final design. And in step number 5, in your final design, you specify what will be the subsystems in your system. What will be their functions? What will be their interfaces? What will be their interaction behavior? So these steps complete your architectural design. Here is the architectural design. And finally, you give a last review of your architectural design to check up if all of the requirements are met, if all of the objectives are met or not. And the feedback is given to improve any of these stages, any of the steps. Let's see these details one by one. Here in this slide, I showed you the brief of I told you the brief of all these steps. We are going to see the details of all these steps one by one. Okay, in the first step, that is determine architectural design objectives. So some of the objectives can be that we want to develop our system for ease of change and maintenance, or some of the parts we want to use ready-made, yani commercial off-the-shelf parts are there, we will not develop it. For example, if you want to get the location, instead of that you write the whole code for getting the location, it's better that you use some of the existing location services like Google service and use their code. They will find the location for you and give to you. So these are commercial off-the-shelf parts that you can decide that you will use in your software. Then next objective can be that you want a real-time system. What does real-time system means? It means when you are asked, for example, I am giving you this lecture and you are listening this lecture in real time, right at the same time, okay, without further delay. This is real time. Another possibility could be that I give you lecture, yani I record it and I send it to you, or I upload it on Blackboard. You can download it anytime when you feel feasible and you are free. That will not be real time. Okay. And also in your system, you should have to look for if you are doing some transactions or how many transactions will be used. For example, in past, like 1 month or so, 1 month ago, we were not delivering our they would have installed some servers 1, 2, 3 on for the Blackboard, and it was working fine. But when we started delivering lecture, yani all FCIT or maybe the whole university was on Blackboard, all the teachers, all the students, then it means there are a huge volume of transactions on Blackboard. So, and it was not working fine. There were a lot of problems. But later on, they improved it. Perhaps they installed new servers or they installed new software components, and now, mashallah, it's working fine. So, what kind of system performance we are looking for? Real time or huge number of transactions, etc., etc. And reliability of our system, security, software fault tolerance, recovery, all these can be our objectives. It depends upon what our project is, what our software system is. So we have to determine if any of these objectives are corresponding to our system. Okay, step number 2, we have to determine the type of the system, what type of system we are going to make. So here would be, you would definitely be thinking of, okay, can we know what are the existing type of systems? Answer is yes. There are 4 common types of systems which are available. First, interactive system. So number 2, event-driven system. Number 3, transformational system. And number 4, database-oriented systems. So we are going to see their description or their explanation in the next coming slides. But here, the pictures also tell you some part of the story. Let's see that in our next slides. First of all, interactive system. As the name tells you that there will be a user or more than one users, they will be interacting with the system. What do we mean by interaction? As if you remember, I explained this to you in our previous classes, that it means you are talking to system, you are sending a request to system, system is responding you back. Then you have some next request, the system responds you back. Then you have next request, system responds you back. So interactive systems can be characterized by actors, which can be human beings, or which can be a machine, which can be other software systems, plus interactions with the computer-based system, yani your system, yani your software that you developed. So human beings are there, or other software components are there, other machines are there who are interacting with your system. And since we are designing interactive systems, so it means there is a significant amount of interactions, not 1, 2, or 3, significant, a lot. Like when you go to, for example, ATM. Your ATM is an interactive system. You send a request to ATM, ATM responds you back. Then you send next request, ATM responds you back. Then you send next request, press next button, ATM responds you back. You are continuously dealing with the ATM. When you are working on ATM, you are continuously interacting with ATM, and ATM is responding you back. These kind of systems, even more than this is a very small example, even more interactions can be there. Okay, all the interactions, they begin with an actor and they end with an actor. Yani requests are sent by actors and responses are also sent to an actor, to the actor, whoever sent the request. Next is, whenever the system receives the request, it must respond to the request. It cannot ignore the request. That is the characteristic of interactive systems. And interactions, usually there is a fixed sequence. Sequence means order. Usually there is a fixed order of actor request and system responses. Like when you interact with ATM, there is there is a fixed sequence. For example, first of all, it asks you to insert card. You insert the card, then it asks you for a password, your password phrase. Then next screen, it asks you, what do you want to do? Now for the next actor, the sequence will be the same. Next actor, sequence will be the same. So usually at every step, what you can do next, these are fixed. These do not change from user to user or day to day or any other, based on any other environment or any other responses. It does not usually change. These keep fixed. You can also consider this system as client-server relationship. Yani the actor who is sending the request is client, your system who is responding to the actor, your system can be considered as server. Okay, our second type is event-driven system. Last time I explained you, not last time, actually more than one lectures, I explained you in details what are the events. So here, our second type of systems that you can design are event-based. What is an event? Event is basically a significant occurrence or change in the system or in the state of your system. It can be, event can be internal or event can be external. You can say an event is something that happened to which your applications need to react. Something has happened from externally. Usually events are external to your system. Look at this picture. This is your system. This circle shows your system, and these are external events. Yani something externally happens, and the request, that the information of that event comes to you, and then you respond to that event. So event-driven system, they capture the events, external events, and it includes the communication of the events, processing of the events, and persistence of the events. Yani whatever the events are happening, you are dealing with all of the events. So event-driven systems are characterized by these four major operations: capturing of the events, communication of the events, processing of the events, and persistence of the events. Okay, as I said to you that usually the events are external from the external entities, but they can be internal entities as well. Your event-driven system, it can work with more than one events at the same time. Wow, this is good. This is really interesting. That means you need highly efficient system inside, because the events can be 1, 2, 3, 4. It can be many. A lot of external requests can be there. A lot of, sorry, events. External entities who can send you events, they can be hardware devices, or they can be software, or they can be human beings also. The order of occurring of the events, there is usually not a fixed sequence. As in your interactive system, you had a fixed sequence of actor requests and system responses. However, in your event-driven system, this sequence is not fixed. Events may arrive randomly. We do not know which event will come first and which event will come later. Another important characteristic of event-driven systems is that we don't have to respond to every external event. We don't have to respond to it. Okay. Contrarily, here in your interactive systems, all the requests must be responded. But event-driven systems, some of the events, they can be ignored. It depends upon the type of the events or importance of the events that to which we need to respond. Our third type of the systems are transformational systems. We have, alhamdulillah, studied it before, so I will quickly revise it to you. Our transformational systems are the systems which process a lot of information. Okay, so we have a workflow through which we process the information. Our workflow can include sequencing, conditional branching, parallel threads, synchronous and asynchronous behavior. So in our transformational system, usually we are working on a lot of data. Usually we are working on a lot of data. So in our request, we are given a lot of data, and will be processing on the data, and usually it takes a lot of time. For example, on 26th of every month, the banks or the organizations, they send salaries. So consider that there are thousands of employees of an organization, and they want to send them salaries. So there will be thousands of requests that will be processed on 26th. So if you are processing a collection of the requests, it is called a batch processing. In a batch processing, there is a collection of requests, not one, two, or three requests. There are collection of requests that you will be processing. Okay, see here, transformation systems, they perform number crunching. Number crunching means a lot of numbers data, a lot of digital data is there that will be performed. Number two, uh, there are computational intensive algorithms, like you are at performing addition, subtraction, division, or something which is using a lot of CPUs. Any other thing which is using a lot of CPU, that is called computation intensive. Okay, again, in these systems also, the actors can be human beings. These can be internal or external devices, or these can be subsystems. Our next type is that is recursive systems or subsystem. Very interesting. This is very interesting. Look at this picture. This is not a software system, but I put this picture just to show you. You can realize that this bigger system, if we can consider it a system, this bigger system is made up of smaller systems which are alike. Yani very similar subsystems we are using here to develop bigger system, then that bigger system is used to develop even bigger system, and then that bigger system is used to develop even bigger system. So that is called recursive use of systems and subsystem. You are developing some small systems, and then similarly you are adding more of these components, and then you are making bigger systems like that. uh, those systems are called recursive systems or subsystems. There are many types of systems in which you can apply this design, this architecture. All right, so let's see this slide. Yeah, this slide is good. We are going to see now. I showed you different types of systems: interactive systems, event-driven systems, transformational systems, and other three are there. These are not, we are not studying it here, but these are listed here for your ease. For these types of systems, what are the architectural styles or architectural design that you can use? For your interactive system, you should use n-tier architecture. For your event-driven system, the architecture name is also event-driven. For your transformational system, the name of architecture is main, program, and subroutines. For your, if your type of system is client server, architecture is also called client server. For your other distributed or decentralized system, you can use peer-to-peer. Okay. For your heuristic problem solving, there is an architecture. Its name is also Blackboard. It's not the Blackboard software we are using. It's the name of the architecture. So we will study today, inshallah, the first four: n-tier architecture, event-driven architecture, main program, and subroutines architecture, and client-server architecture in our next slides. Okay, if you have interactive systems, you can use n-tier architecture. N-tier, N means it is variable. It can be 1, 2, 3, 4, 5. Usually it is more than one. Tier means layers, as we have discussed before. So this is a tier or layer. This is a tier or layer. This is a tier or layer. Tier or layer. Tier or layer. For example, you have a user. User sends a request. It passes through the tier 1, which is your GUI tier. Then the request passes through tier 2, which is a controller layer. Then the request goes to next tier, which is business object layer. Then the tier goes to next tier, then the request goes to next tier or next layer, that is database layer, and then next tier, which is network communication layer. So here you have 5 tiers or 5 layers. Better word is tier. We should use tier. Everybody understands what is a tier. When you are designing your interactive system, the architecture of your software system is usually n tier, so it can be 4 tiers, it can be 5 tiers, it can be 6 tiers, or whatever the number of tiers you want to use. That is why we use n here, which is a variable. Next, very important architecture is your client server. In client server, what happens? There is a central server. It can be one or it can be more servers, and all the clients, they send their request to the same server. For example, you are using Google, different through different devices, your laptop, your mobile, your desktop, you are sending requests to Google servers. As you know that the Google server can be one or more, so the requests through the internet are sent to the server, and the server or servers, they respond you back. So you are sending the request, there is a machine which is responding back to your request. The one who sends the request is called client. One who serves or responds to your request, that is called server. Here is another example of a client server. These are the clients, client machine, the laptops, and they send requests to the servers. On the server side, you have more than one servers. They are connected to the databases, and those servers, they respond you back. If one client sends a request, only one server is enough. Usually one server is enough for several of the clients, maybe 5 or 10, or depending upon the number of clients or their machine efficiency. If there are more clients, like nowadays there are a lot of people who are using Blackboard. Consider that there is only one Blackboard server. What will happen then? Of course, that server will not be able to respond to all of the requests. Okay, and then the service will be down, Blackboard will be down. Like many people complained at the starting of the starting days of our online lectures, that the Blackboard is not responding. So then they have to install more than one server, so that they can allocate some of the requests to server number 1, next request to server number 2, next set of requests to server number 3, and so on. And then everybody is happy. This is an example of client server based system for airline reservation system, like Saudi Airline, like any other airline. How does this work? Here are the clients, yani these are the offices, or their offices, or the clients can use online system from their home. So there are a lot of clients, there are a lot of offices, and then they send their requests to Saudi Airline servers. And Saudi Airline servers are not only one server on the back end, there are many servers. In this picture you see only 3. Okay, then there is one machine which is just balancing the load of request. This machine is receiving all the requests and allocating requests, dividing the request to these servers. This component is called load balancer, because it is balancing the loads of client requests. Some of the requests are allocated to server 1, some to server 2, some to server 3. Okay, then these servers are basically working with the databases on the back end, which are Saudi Airline databases. They are storing all the records of airlines, the flights, then the clients and the customers. So these servers are working with the databases. Of course, if there is databases stored at only one location, it will be a disaster. So that's why they have to replicate, because there are many clients, there are many servers. So similarly, the database should be replicated to more than one location. Okay, this is the UML diagram of client server architecture for airline reservation. These are your clients. This is your flight information system. Yani these are your, this which is installed on your servers, and the servers are working on the back end with the databases. So this is just a UML representation of your client server architecture. Our next type of architecture for your transformational system, and the architecture style is main program and subroutines. So if you have your, you are developing your transformational system, your type of the system is transformational. So this is the architecture that you should use. So you should have a one main program, and that main program should have some subroutines. Okay, so you can say in this picture, this is the UML stereotype picture. and UML stereotype to show the software components. So you will divide your program into different subroutines. Subroutine number 1, subroutine number 2, and those subroutines may call different subroutines in further. For example, subroutine 1 is calling or using subroutine 3 or subroutine 4. Similarly, subroutine 2, they can use subroutine 5, 6, or 7. So like that, you have your main program which is using different sets of subroutines, and subroutines can call or use other subroutines. Next, the architecture is event driven. So this is your main software system, and these are the external components, component 1, 2, 3, 4, which are sending the events to your software system, and your software system is processing those events and then communicating the response back to the components. Our next step, number 4, let me take you back to our major picture. We are just here at step number 2, determine the type of the system. We saw different types of the systems and their characteristics. Now we are further going to our next step, number 3 and step number 4. So from the existing, you can apply any one of the architectural design depending upon your type of the system you are making. And next, our next step will be after you apply anything you apply any of the existing ready-made architecture, there is a necessary need to do some of the customization. So let's see number 4. This is your step number 4, perform custom architectural design. As I told you that not all application systems development projects, they can reuse the existing architectural styles. You have to do some of the custom design. Custom architectural design is required to meet the needs of an application system. And of course, you can use different design patterns for your custom architectural design. The patterns we studied in our last chapter, all those patterns, not last, the one before it. You can use any of the existing patterns in your to make your custom architectural design. Okay, in step number 5, we specify the functions and the interfaces between the components of our system. And before we decide the functions or interfaces of the components, first of all, we must allocate all of our objectives and requirements to each subsystem. Of course, in our system, we will have different subsystems. We should allocate the requirements like we did in our, I think, chapter number 2. Yeah, I think in chapter number 2, we allocated different requirements to different components, that this component will meet the requirement number 1 and 2. The next component will meet requirement number 3 and 4, like that. And similarly, we also allocate the objectives of our system to different subsystems. This objective will be met by this subsystem. This objective will be met by this subsystem. So we have to be very precise so that nothing is missed. Then after, we specify the functionality of each subsystem as well as inside each component of the system. What component will be performing which functionality, and overall functionality of the subsystem. Next, then we decide how the subsystems and the components will be interfacing with each other. What do we mean by interfacing, guys? As I explained to you a couple of times before, I'm repeating here for you so that you can remember. Interfacing means how they will be interacting with each other. What will be the methods they will be using to interact with each other. For example, I'm the instructor, you are the students. How we are interfacing with each other nowadays through Blackboard. And previously we were interfacing in classrooms. Then we were interfacing in our labs. Then we can interface with each other through mobile phones or with emails. So these are all the methods through which we can send and receive messages. Next is interaction behavior. What kind of interaction we can have? Like student and teacher, we can interact for your problems of course 250. Class problems, class lectures, and lab problems. This is our interaction behavior. We are not discussing any other course here. This is also our interaction behavior. We are just discussing our course problems. This is also our interaction behavior. The last step is review. When we are doing the review, in step 5, our architectural design is complete. So finally, we are giving a final check to check if we have dealt with all the design objectives. Are all the design objectives properly allocated to our software systems? Do we really meet our objectives? And does our design satisfy the software design principles? I think it will come in next slide. We have already discussed software design principles in our patterns chapter, where we discussed different software patterns. I have allocated, I think some slides are here. Yeah, it's here. Just as a revision, you should check on that our software satisfies the software design principles and our security requirements are met. This is very important nowadays. The system must be very, very secure. So a lot of emphasis you should put on security requirements. For your revision, these design principles have been placed here once again. So what are the principles I am repeating here for you? Number 1, you should make your design for change. That in possible in near future or far future, there will be change. Nowadays, requirements are changing very quickly, very fast. Very fast, I do not mean these are changing in hours, but I mean in, for example, months, or in 2 months or 3 months or 6 months. The requirements are changing because world is changing very fast. So you should make your design which is easy to change. Separation of concerns. The problems or the functions or the tasks you should allocate separately to different objects, and there should be no overlapping of the concerns among the objects. Information hiding. This is the basic principles of your object orientation, that information of each object is hidden inside the object. You kept them private and you provide public methods to access that information, to set and access those information. High cohesion. This is another very important target. Low coupling, and you always try to keep your object simple and stupid. This is, whenever I read it, I smile and I explain to you a couple of times that what are the stupid objects, that your business logic should not be in other objects. So business logic should be put in your main function, where you are having your main. You should put your business logic in main function. All the other objects should be kept simple and stupid. Okay, so here are some of the guidelines, overall guidelines for your architectural design, that you should try to adapt an architectural style. Whenever it is possible, use the existing architectural style. Instead of that, you try to make something new. This is not advice. Advice is try to use an existing and try to make changes in existing styles. Always try to apply software design principle. Try to apply software design patterns wherever it is possible, because these are the existing solutions to a lot of problems. So if you are using patterns, you will be secure and safe from a lot of the future problems. Always make a list of your objectives, and always map your objectives to your subsystems very precisely, and make a final check if you are meeting your objectives or not. And repeat those steps, repeat any of the steps whenever these are needed. No need to take panic, no need to do hurry, no need to destroy your efforts by hurrying up. Always repeat something, iterate something, and you do it and again do it whenever you feel that something is not perfect.